Now let's talk about traps. Yeah, I'm showing you a fun picture of a trap in literal sense. So but what we do in the subsurface as scientists and engineer will be to, find out what are the arrangement, what configuration can keep oil in place. Okay. And then we also ask the question of how and when did this happen? Because it's important to keep in mind timing. At what time did oil, the hydrocarbon, migrate into this reservoir? As at that time, was the reservoir in a shape, did it have some kind of configuration that will prevent the oil from escaping? Does it have a seal around it? Does it have the geometry or the shape of like an anticline or a dome? Can it keep hydrocarbon? So these are the questions that are typically asked. And that's what this other figure will also help us understand. How do we find oil and gas? What we do beyond understanding the geochemical basis, the rocks, source rocks, are they mature? We ask ourselves, is there a reservoir? We've looked at that, okay? And the answer to that is yes. The next question will now be, okay, are the reservoirs sufficiently, are they sufficient enough in terms of their capability, porosity, permeability, and all of those? And the answer is yes. The other question we'll now ask is, okay, when did the oil move from the source rock to that reservoir? As at that time, did we have a seal rock or a trapping configuration to prevent the oil from going all the way further to the surface? Because nothing stops the oil from getting to the surface, right? So we find a way to better understand, okay, what oil move into it? Did we have faults that will allow the oil to escape to the surface and all of those? Okay. So this is just that example. And then this other one shows, again, a typical trap configuration. You see where the oil rigs are placed? They are placed on the top of the anticline, what we call an anticline, or what some people might call a dome. But what you see to your right is that everything potentially works, right? The oil is trapped. If you look at the figure, the oil is trapped. But you know that gas has a higher capillary entry pressure. In other words, gas can still force its way through and get to the surface, even when the oil is trapped. So gas can be leaking gradually while oil is still in place because gas has a lot more energy to pierce through the rock cracks. And then to your left, you also see that this configuration is not to your left. You see that the trap is not properly formed. Okay, the reservoir rock here, which is this white patch with the orange dots, gets all the way to the surface. So whatever oil that's making its way from the source rock gets here to the first reservoir, is trapped. When it gets to the second reservoir, it goes through these faults and migrates, and it finds its way all the way to the surface. And that is just how what we saw at Okitipupa, the bituminous deposits there, and what we also saw at in some parts of the east in Enugu, Gweme oil seep. I'll show you the video. This is how it happens. The oil found its way through some crack or fault and gets all the way to the surface because the trap failed. But in some other scenario, what it tells you is that if the trap failed in one location, nearby, you may have a place where the trap is successful, just like you're seeing to your right, where the oil is in place. Okay, and this is showing just an example of a subsurface representation. This is seismic data. The idea here is to show you how even the subsurface can be very complex. So I'm showing you two things here. The seismic is the subsurface, right? This is in Niger Delta. While to your bottom left, this is on the surface. This is somewhere in Ireland. These are just showing you examples of how the surface occurrences can help us better understand the subsurface. You will see this analog we see on the surface here, right? This is what it looks like when we do a sketch of it. And this is how we go from the surface to the subsurface, because at the end of the day, it's the same signature, right? The seismic data you see here is subsurface data. But again, you and I are not there. We're only looking at images and trying to make sense of it. And sometimes the quality of your image may not be very instructive. So you find a way to use analogs or other offset data to better understand what the trapping configuration is. So these are some other fun surface examples. These are not from the internet. These are pictures that I also have taken. This is a case where the rock has been squeezed. Look at this nice anticline. This is another what we call chevron fold. the rocks have been squeezed and, deformed significantly. Here, these rocks have been squeezed and stretched, and here they've been stretched. So these are all things that might lead to creation of a trap one way or the other, but these are all structural traps.